Okay.
Okay. Hello, Professor. We started off with the reference router provided by you on the NetFPGA, and we created a star kind of topology like this. And we started off with testing the initial reference router without the mini IDS without the mini IDS block. So we tested out the communication between these routers using the iperf and tested for the clear route so that each of the nodes receive data from every other node as well. And and we used RK for getting the forwarding table, and the report log files, whatever we got, we have automated. We have built a parser where we automatically pass the router IP addresses, and uh, run the command so that we don't have to set up every time. And even if there is a change in topology, or there is a change in the IP address of these nodes, when we instantiate again, it automatically takes out the values, and we don't have to run it again and again. Uh, and after testing out these scripts and the communication between the communication of these links, we basically tried out with the net file, uh, the bit file which we created. So Dia will explain the IDS overview, and then what we created, and then later on Manoj will be explaining the our simulation uh, along with every one of us. So yeah, Pia, want to take?
Go.
Are you recording? Should I go?
Yeah, yeah.
Okay, so this is the structure of our IDS. As you can see on the right hand side, we have a finite state machine receiving inputs from the hardware and the software registers. And all of these patterns are getting passed from the finite state machine to the pattern matcher. And whenever data comes in, it gets pushed to a drop first in, first out, and also into the pattern matcher. And how the pattern matcher works is that we are looking at the packet contents at a moving window, and we compare it with all the patterns that we're interested in. So let's say that we're looking at the location 0 to 5 of the incoming packet, and we try to compare it with all the patterns that we have in the pattern matcher. And then we would move the window by one location. So now we're looking at location 1 to 6, and we do that all the way till the end of the packet to compare it with all the patterns that we have stored in the matcher. And this process, even though might seem lengthy, can also be done in parallel, and we can look at several different pattern matchers or different windows at the same time by just fitting in more pattern matchers between the FSM and the drop FIFO. And if we ever see a pattern gets matched, then we can just tell the FIFO to drop the packet. And from then we can see out of the drop FIFO, we only get data out with filtered packets. And now I'm going to hand over to Manoj.
Okay, so the bit file was generated and then we uploaded that into the topology that we created on Data Lab. And as Sachin said, everything was a script was written to initialize the entire FPGA. So let's now access the control node. now we'll be initializing our design into the FPGA. So initially we do the CPCI reprogramming followed by downloading the bit file that we generated, and then we also reset the IDS reg. Upon resetting the IDS reg, we also look at the IDS matches, and we can see that initially there are 0 matches, and after that we are setting the pattern. In this case, the pattern is going to be bad packed, and after this we'll be testing out the traffic between all of the nodes. So essentially node 0 accesses server, and the rest of the 3 nodes are the clients, and 2 clients will be sending only good packets and 1 client will be sending the bad packets, and we should be able to see that the bad packets are being dropped while the good packets are being sent. So let us look at this in the TCP. Also, the files will be stored in the logs file. So as you can see, the folder is empty now. So now let's go and look at the patterns. So this is our node 0 that's acting as a server, and then this is our node 1 that is sending only good packets, and this is our node 2 which is also sending only good packets, while node 3 is sending bad packets. As we can see that it is connecting to all 3 nodes, but the throughput only is given for just the 2 nodes. And this is happening because TCP expects an acknowledgement from the receiver to send the next packet. But since the bad packet is contained in our data, the packet is dropped by the router and it never reaches the destination. Thereby, there's no acknowledgement received. So this just stalls the third one. So we can wait for a couple of seconds and see that there's still no communication despite the rest of them having finished. So we are manually stopping this, and let's take a look at the log files generated by this. As we can see 3 of the log files, so we can look at them. So this is the traffic from node 1, throughput from node 2, and throughput from node 3. You can see that there is no throughput because there is no data that has been sent. Now let us look at the UDP transactions between the same nodes. The test methodology is similar to the TCP one. Node 1 and node 2 will be sending so node 1 and node 2 will be sending good packets, while node 3 will be sending bad packets. This just is a bit different from the TCP because UDP doesn't expect any acknowledgement, so the data will still pass. So but however, if we look at the TCP dump, we'll see that there is no data that is being received by the node 0. As you can see, again, all 3 nodes are being connected, but yes. So now if we go and look at the we see that there are 3 more UDP files. These are generated by the TCP dump that has been running in the background with the script. Yeah, sorry. So as we can see, there are packets going from N1 to N0, and there are packets going from N2 to N0, but when we look at the packets going from N3 to N0, there are no packets. This is because all the packets were dropped by the mini IDS. The drop in packets can also be illustrated by looking at the matches reg. So if we look at the IDS reg space matches, we can see that it has counted 33 packets in total. This is not a decimal 33. This is binary 33, which translates to approximately so it has dropped approximately 51 packets in the entire run. So this illustrates that our mini IDS actually works and drops the packets that contain the pattern that we don't want to get through.